Hello everybody. I'll show you how to generate this complex solid in Catia V5. Okay. Now open Catia V5 and go to start, select mechanical design and open part design workbench. And here you can enable this hybrid design so that we can create both part features and the surface features and wireframe features within the same body. Enter the part name or enter complex solid and press enter. Right now we are in part design workbench. So this is my specification tree and we are having 3 default planes and we also have a compass. Now we have to generate the model using these 3 default planes. For that I'll take a sketch. I'll use position sketch and I'll select the right plane, and here we can change the orientation of the plane, reverse the horizontal or reverse the vertical, but right now I want to keep the same orientation and click OK. Now at present we entered into the Sketcher workbench. Here I have to generate the sketch for obtaining this model. Okay, so I want to take two sketches. One is the side view and the next one is the top view, and I want to combine these two perpendicular sketches. Now come back to Sketcher, take two line segments in this manner. Now say this is the side view, so first of all let us apply symmetry between these two lines. Select these two lines and the axis, apply symmetry. After that apply the distance between these two lines and I'll change it to 200. Next apply the length of this line and this line and change this value to 50 and this value to 25. Okay. After that you can apply symmetry between this end point and this end point with respect to horizontal axis. Apply symmetry. Next select this point and this point, this axis, apply symmetry. Okay. Now after applying symmetry, take two splines and generate the shape. Okay. Now observe the figure. So here we are having a groove and again depth. So take a spline in this manner and pick this point. You can edit the curvature later by selecting these control points. Okay. Now after that take another spline, start it from this end point, apply coincidence and generate the shape. Exit the command and adjust the curvature. Okay, now it is sufficient. Come back to part design. After that select the top plane and go to sketch. Again reverse horizontal and reverse vertical, click OK. Now here again let us take two lines. So this is my second sketch. If you expand it, see right now we are in sketch 2. Take another line segment. Okay. Now select this line and this point apply midpoint and vertical. Select this line in this point, apply midpoint and vertical. Okay. And there is no need to apply symmetry for these two lines because already we are applying midpoint constraint. Now select constraint and apply the dimension equal to 50, and this is equal to 50. Okay. And see, in the figure we didn't have any dimensions, simply assume the dimensions for getting the nearest possible result. Okay. Now take another spline at this point and generate the shape. Okay, end it. Now adjust the curvature using the control points. Okay, now if this is the shape, select it and apply mirror, and we got the second sketch. So if you spend some more time you can get the exact shape, but see, as this is a demo class, you can do it as. Now I want to apply material between these two sketches, so we have to select the option known as solid combine, click it and select the first sketch under profile 1 and second sketch under profile 2, and we can fill it between normal to sketching plane. Click preview and click OK. Now we got the solid combine, okay, the center portion of this example. Now after that we have to create the cylinders and we have to merge them with this face, and again we have to generate another cylinder and we have to merge it to the next face, but we cannot do it easily in part design workbench. So we will apply surfaces. Okay, we will generate surfaces and after that we will convert the surface into a part by applying thickness or by filling it. Okay, now come back to part, and here actually I created this combine for reference purpose. Okay, at the final stage I don't want this combine, I want to deactivate it or I want to delete it. So while extracting a surface for the solid, we have to remember one thing, that is we have to use, right now I'm not using this create item, simply I'm going to extract the surface. So use extract and select solid combine, click preview and click OK. Now here we got a surface for this solid combine, but see, observe the feature, this is extract 1, and now after extracting it I want to deactivate it because I don't want this combine in the geometry. Okay, so you cannot, but we cannot delete it or deactivate it separately because this extract is generated with reference to this solid combine, and if you try to deactivate it or delete it, the extract will be deleted or deactivated. So while generating the extract we have to remember a point, that is we have to activate this create item. Then if you extract the surface for the solid combine, instead of generating an extract it will generate an isolated surface. Click preview, click OK. Okay, now we got an isolated surface. Now you can simply right click on it and you can deactivate it. Okay, and click OK, but it will not affect the surface because it is an isolated surface and there is no association between combine and the surface one. Now after that I don't want this face and this face, but I cannot delete them directly, because if you right click on it and if you delete it, it will delete the complete surface one. So before deleting these faces, we have to disassemble this surface one into 6 faces. See, here we are having 6 faces. In this surface one, we have to separate them. For that, you can select disassemble and select the surface, and here we are having 6 faces, so we will get 6 cells. Select all 6 cells and click OK. Now we will get independent surface for each face. Now after that, actually we don't want the first surface, that is the complete surface, okay, extracted surface. So simply we can delete it or simply hide it. See, now these are the remaining 6 faces, okay, individual 6 faces. Now select it and delete it. See, I am deleting surface 3, and after that you can delete this surface. Okay, next we have to generate the cylinders, and we have to merge it with this say these edges. Okay, for that we can use multi-section surface. So first of all, let us generate the sections. Say I'll take only 3 sections, but you can take as many sections as possible. It depends upon the accuracy. If you want more accuracy, then you can increase the number of sections, but I want to generate the solid between 3 sections. So first section will be taken on this face, second on this plane, and the third on this face. So select this face and go to sketch. Okay, and here I'll take an arc. Okay, arc starting with the limits, 3-point arc starting with limits, and let us apply coincidence between this point and this point. Okay, after that again select this point and this point, apply coincidence. Okay, you can adjust the curvature or you can apply a standard radius parameter. Now I want to keep it in this manner. Now come back to part design. Okay, after that let us select this plane and go to sketch. Use position sketch so that we can change the orientation, reverse vertical and reverse horizontal. Okay, and click OK. Now here we have to generate another arc. Okay, now we got the arc, but here in the previous case we are having 2 vertex points, so we directly applied coincidence between the end point of the arc and the vertex point. But right now we have to apply coincidence between this point and a point on this edge. Okay, and that too the point must lie on both the edge and the plane. And what is that point? It is the intersecting point between the spline and the plane. Okay, so the plane is the sketching plane. See, this plane is intersecting this plane at a point, this curve or edge at a point. We have to generate that point for applying the coincidence constraint. So use intersect 3D element and select this edge. Now we got a projection, that is the intersecting point. Convert it into construction. Again intersect, select this edge, and already it is construction element. Now select this point and this point, apply coincidence. After that select this point and this point, apply coincidence. Click OK. Now adjust the radius and we can directly use this edge as the third section, or simply extract it. Come back to part design, and here we are having extract this edge. Okay, now click preview, click OK. Now we got the section. Now after that, use multi-section surface. So this is multi-section surface. Select the first section, second section, and the third section is extract. Now reverse the direction. Okay, and simply click apply ratio as the coupling mode, or you can take vertices, click preview. Now we got the surface in this manner because we didn't apply the guide curves. Select guide curves, and the surface should be generated between these two guide curves. Okay, now these two edges are the guide curves. Simply click preview. Now we got the exact surface. Click preview and click OK. After that, I want the same surface on the other side. Okay. And the difference between multi-section solid and multi-section surface is, for the multi-section surface we can apply symmetry, but we cannot apply symmetry or mirror for a multi-section solid. So select it and apply symmetry about this plane. Click preview and click OK. Now we got the same surface on both the sides. After that, select the surface and go to sketch, reverse vertical and reverse horizontal, click OK. Now take two circles here and here without applying these constraints. Sorry. Simply select the circle and this edge and apply coincidence. Select this edge and the circle and apply coincidence. Click OK. Now after that, you can come back to wireframe and surface design and apply extrude. Okay. Increase the first limit and keep the second limit equal to 0. Click preview, click OK, and click OK. Click cancel. Now after that, see here we have to trim the surface. Okay. For that, select split. Okay, I want to split this surface with this extrude. See, with these two cylinders, and see it is splitting the surface. Now click preview and click OK. After that, we have to close these faces. For that, you can use fill this boundary, click preview, click OK. Again, fill this boundary, click preview, click OK. Now we got the surface. Okay, and after that, you can join all the surfaces. See here, fill one, split. In this case, split is the surface. Next, extrude. After that, symmetry, multi-section, and here extract is a line segment. Okay, wireframe element. There is no need to select it. Again, surfaces and click join. See, these are the surfaces. After selecting all the surfaces, you can join them. Okay. Click preview and click OK. Next, say I want to convert it into a solid, so I will go to part design and I will apply close surface. Select close and select the join. Okay, we will get the join because already we joined the surfaces. Click OK. After that, you can hide this join. Now we got the solid. Okay. Now go to tools, hide all points, tools hide all sketches, and tools hide all curves, and tools hide all planes. Okay, now this is the final solid, and you can go to rendering, change the rendering. If you spend more time, you will get the exact shape, but this is the basic operation how to generate a solid.